Hello, today we're going to be talking about graphing proportional relationships. And if you remember, proportional relationships goes back to what we talked about at the beginning of the school year. So you might be thinking in your mind, y equals mx. And also, since we see a graph here, we want to remember that for a graph to show a proportional relationship, the graph must show a straight line that goes through the origin. Just in case you're curious, topic 14, this is topic 14 in the pre-algebra version of digits. We're going to just jump right into some examples here. So number 1 says that a video game store has a frequent shopper program. You earn 4 points for every video game you buy. Draw a graph to model this situation. You need 48 points for a free game. So how many video games do you need to buy to have enough points for a free game? So when we look at this here, you can kind of say to yourself, well, I don't really know how I'm going to set up my graph just yet, but I want to look back at my information and it says that I earn 4 points for every video game that you buy. So when I'm looking at my X and my Y axis, the X they've labeled as the games purchased, and the Y they've labeled as total points. So I'm going to have to figure out how to set up my scale on here. So I'm going to say, since I need to reach 48 points for a free game, I can't start by going 4, 8, and so forth, because I won't be able to put 48 on the line. So I'm going to start this always starts at 0 at the origin, so this one's going to be 8, then 16, 24, 32, 40, 48, 56, and 64. So each box on the y-axis has a scale of 8. So then here, just to keep things nice and even, I'm going to say that each box on the x-axis has a scale of 2. So 2, 4, 6, 8, 10, 12, 14, 16. So again, if I wanted to think about how to draw this here, if I earned 8 points, that would be 8 divided by 4 points would give me 2 free games. So that would put me at the point here. Because you're thinking about with your x and your y coordinates, that x represents the games and the y represents the points. Sorry, my hand's right in the way. So I'm going to continue this pattern, that if I now if I earned 16 points, well, 16 points divided by the 4 points to get me the free video game, that would mean that I end up with 4 video games. So if I keep going with the pattern, and I know that there's other ways to do this, but we have to have the graph filled in. If we go in with the pattern here, I see that this point right here is the point 12, 48. 12 games, 48 points. So I know that I can buy 12 games. And again, I know that you guys probably would not have used the graph here to get your answer. So if you wanted to think about with a proportion that for 4 points that gets you 1 game, then if I have 48 points, or I need 48 points, how many then video games do you need to have enough points for a free game? That would be solving my proportion by going 4 times x equals 48, divide by 4, get x equals 12. Now, the other thing I need to point out here is that you are not going to connect the dots. And I know that that's something that you really always do when you graph. You usually connect your dots. But what we're trying to show here by not connecting them is because I'm not drawing a line here, if I have 1 game purchased, or excuse me, if I had 1 game purchased, it's not going to get me enough points to that I won't earn enough points from that. So let's say that I had 10 points. That's somewhere between the 8 and the 16. I can't then say 10 is around here and then travel over to my line, because you can only earn in 4-point increments. So because not every point on the line, if we were to connect these dots, represents that, you can't connect your lines. And I know that might be a little bit confusing, so we'll just practice that again. since there's no data point at that on the line, you can't connect it. So number 2 says that your school is selling raffle tickets as a fundraiser, and that the raffle tickets are sold in groups of 4 for $3. Draw a graph to model the situation where the horizontal axis is the number of raffle tickets purchased and the vertical axis is the total cost. You have $21, so how many raffle tickets can you buy? So they've done a big favor for us here by labeling everything on our graph, but they did remind us in our sentence that X is on the horizontal is the number of raffle tickets and Y is the total cost in money. So if you have $21, we want to figure out how many raffle tickets you can actually purchase. Well, since we know that the raffle tickets are sold in groups of 4 for $3, that if I have $21 and I divide that by the $3, that is telling me that I can get 7 groups. And since there's 7 groups and there's 4 tickets in a group, 7 times 4 would give me 28, which means that I can purchase 28 raffle tickets. So that alone is not enough to answer the question here because they also wanted us to label this here. So again, the difficult part is trying to decide how to make our data, our information fit on our graph. And so if the number of raffle tickets are sold in groups of 4, I'm going to say that I'm going to go up by 4s on my x-axis. So 4, 8, 12, 16, 20, 24, 28, 32, and 36. And then for my total cost, since the bundles are sold for $3 each, one bundle will be $3, 2 bundles would be 6, 3 bundles would be 9, and so forth. So I'm going to go up by 3s here. So again, you have to think if we're going to eventually be connecting our dots here. And since I can get 4 raffle tickets for $3, I do have a data point right there. If I double the amount of tickets that I purchase, so I get 8 tickets, that will cost me $6. If I triple that, 12, then for $9, 16, and so forth. So we can kind of continue to see this pattern going on. And again, if it says I have $21, which here's $21, so I travel over on my line, there's 21, so the corresponding X value is 28. So we get the same answer from doing this too, just by graphing it. So again, since I can't buy tickets in any other number besides a multiple of 4, the data point of 6 raffle tickets would not be on this line. So since it's not on the line, I can't connect the dots. Moving on. So our key concept here says that we have 3 ways that we can express relationships, which we've already discussed. That you can have a table, a graph, and an equation. A table shows a proportional relationship when one quantity is a constant multiple of another quantity. A graph shows a proportional relationship, again, we've said this, when it's a straight line that passes through the origin. An equation in the form of y equals mx represents a proportional relationship. Again, in the equation, m is your constant proportionality, or it can be written as y over x. So again, they're just reminding us here that proportional relationships can be shown using these 3. They're showing us in this table that each y value is twice the x value. So if each y value is twice the x value, your equation would then be y equals 2x. And when we go ahead and graph this, we would just say, okay, here's the point 0, 0, here's the point 1, 2, here's the point 2, 4, and we show that it's a straight line traveling through the origin. Okay, having fun yet? Number 3 says that a salesperson earns a 10% commission on sales of energy-efficient appliances. Draw a graph to model this situation, and is the amount of the commission proportional to the amount of sales? How do you know? So I'm going to first start looking at this I can't go right to my graph here. I have to first go to the information that's given to me. They are reminding me here, sorry, it's a little crooked, that sales is on my X. I don't know what's going on here. Sales is on my X, and the commissions is on my Y. So when I set up my table, I'm going to put sales in the X, which is in dollars, and the commission in the Y. This is my X, this is my Y. And I'm just going to choose numbers that are useful for me. Normally when we set up these tables before, I had to use 0, 1, 2, 3, 4. So let's think about 0. If you have 0 sales, are you going to make any money? Well, 0 sales, 0 commissions. So right there, that's telling me that this does go through the origin. So I know this is going to be at 0, 0. Then, instead of saying $1 in sales, how much commission would I make? Because $1 in sales, so 10% commission would only be 10 cents. I'm going to try to use numbers here that would give me whole numbers. So I'm going to say that if I sell $100 worth of appliances, I get 10% of that. 10% of 100 is just 10. Because to find 10% of a number, you move the decimal point over 1. So the commission would be 10. Then I'll say, okay, if I sell $200, because it's easy if I have a pattern set up here. If I sell $200, I'll get 10% of that. So that will be 20. If I sell $300, and so forth. If I sell $400, I'll get 40. So I'm just giving myself some numbers here. So now I have to set these numbers up on my x-axis here. And I could go 100, 200, 300, 400, 500, but that might make my graph a little, like, it might kind of be tough to read. So I'm going to just go, yes, each box is worth 100, but I'm only going to label every other box. So I'm going to label this one 200, label this one 400, label this one 600, and then 800. Even though we didn't get to those numbers, I think it would be easy to figure out what your commission is. So then over here, also on the y-axis, I'm going to make each box worth 10, but I'm only going to label every 2 boxes. So 20, 40, 60, 80. And from my graph already, we said that it does go through 0, 0, 100 and 10 will go here, 220 will go here, 330, 440. So if I notice that already, it looks like I've got a trend. Now, this one's different than the first one because you can sell something in between these numbers over here. You could sell something that cost $150. You could sell something that cost $137.27. Because that data value can be plotted on your graph, you do want to connect your lines, or your dots, so I am going to draw a line. Draw an arrow at the end of the line to show that it continues off in a pattern. And so they said, is the amount proportional to the amount of sales? How do you know? I said, yes, the graph is a straight line that passes through the origin. Passing through the origin. Okay. So I'm going to have you guys try number 4. I'm just going to give you a little hint here so that you know how to fill this in. Again, I'm telling you that the car rentals is here, cost is here, tax is here. And I'm just going to give you these values so we all end up with the same answer. I'm going to put 50 and then 100 and then keep following that pattern. So if you could give that one a try. Okay, so this is the final result. I don't want anybody to be in a panic if your graph looks slightly different, like if you have different values on your x and your y axis, if you have your spacing differently even. Just the end result on your paper should be a straight line that's still passing through the origin. So now I wanted to look at number 5, which, as you notice at first glance, is a little different here because we've got our x-axis traveling this way and our y-axis traveling this way. This just means that we're going to be graphing in a different quadrant on our coordinate plane. So number 5 says that ice forms at 0 degrees Celsius. The surface temperature of the ice on an ice rink decreases 0.5 degrees centimeters every hour. Draw a graph to model this situation. Start when the surface temperature of the ice is at 0. So if the ice forms at 0 degrees, when it just hit 0,